For centuries, humanity has gazed up at the stars, filled with wonder and a yearning to explore the unknown. The night sky has always been a source of inspiration, a canvas of endless possibilities that beckons us to dream beyond our earthly confines. As our species has grown, so too has our thirst for knowledge and our desire to find new frontiers. The advancements in space exploration technology have brought us closer to the stars than ever before, igniting our imaginations and fueling our ambitions. But what if, amidst the vastness of space, there exists a world where humans could one day thrive? A place where we could build a new chapter in the story of humanity, a second home that offers hope and opportunity. What if we could make Mars, our red neighbor, into a second home for humanity? Imagine a Mars with blue skies, flowing rivers, and lush green landscapes, a world transformed by human ingenuity and perseverance. The idea of transforming Mars from a cold, barren desert into a habitable world may seem like the stuff of science fiction. Yet, with each passing year, the dream edges closer to reality as we make strides in understanding the red planet's potential. Yet, the possibility of terraforming Mars, as it is known, has captivated scientists and dreamers alike for decades. Researchers and engineers are tirelessly working on innovative solutions to overcome the challenges of creating a sustainable environment on Mars. It represents a bold vision for the future of our species, one that pushes the boundaries of science and technology. This vision challenges us to think beyond our current limitations and to embrace the spirit of exploration and discovery that has always defined humanity. In our search for life beyond Earth and the potential for human settlement, Mars has emerged as a prime candidate. Its proximity to Earth, relative to other planets, makes it a more attainable target for exploration and potential colonization. While Venus, often called Earth's sister planet, is closer in size and gravity, its extreme temperatures and toxic atmosphere render it inhospitable. Mars, on the other hand, possesses tantalizing similarities to our own planet. It has a 24.6-hour day-night cycle, polar ice caps that expand and contract with the seasons, and geological features suggesting a watery past. These factors make Mars not only a fascinating subject for scientific study, but also a potentially viable candidate for terraforming. Before we delve into the possibilities of terraforming, it is important to understand the current state of Mars. Today, Mars is a frigid desert world, its surface scarred by ancient volcanoes, vast canyons, and impact craters. Its atmosphere, composed primarily of carbon dioxide with traces of nitrogen and argon, is incredibly thin, about 1% the density of Earth's atmosphere. This thin atmosphere provides little protection from the sun's radiation, and the average surface temperature is a chilling -63 degrees Celsius, or -81 degrees Fahrenheit. Water, essential for life as we know it, exists on Mars primarily as ice locked away in the polar ice caps and beneath the surface. One of the most crucial steps in terraforming Mars is raising its surface temperature to a level that could support liquid water and a more Earth-like atmosphere. One proposed method involves the use of greenhouse gases, which trap heat from the sun and warm the planet. While on Earth, we are trying to reduce greenhouse gases. On Mars, they could be the key to making the planet habitable. By introducing super greenhouse gases, such as chlorofluorocarbons or perfluorocarbons, into the Martian atmosphere, we could potentially trigger a runaway greenhouse effect. This process would involve trapping more of the sun's heat, leading to a gradual warming of the planet and the potential melting of the polar ice caps. Section 5. Unlocking Mars potential. Melting the ice caps. Melting the Martian ice caps, which contain vast amounts of frozen water, is another critical aspect of terraforming. This water could be released into the environment, creating rivers, lakes, and even oceans, which would be essential for supporting life and making the planet more habitable for humans. Several methods have been proposed for melting the ice caps, including the use of orbital mirrors to reflect sunlight onto the poles, deploying dark, low-albedo material on the ice to absorb more solar radiation, and releasing super greenhouse gases, as mentioned earlier. Each of these methods has its own set of challenges and potential consequences, which would need to be carefully considered. Section 6. Shielding a new world. The quest for a magnetic field. Mars lacks a global magnetic field, which on Earth acts as a protective shield, deflecting harmful solar wind and cosmic radiation. This radiation poses a significant threat to any potential life on the Martian surface and would need to be addressed before humans could live there permanently. Creating an artificial magnetic field around Mars is a monumental challenge. One hypothetical solution involves generating a magnetic field using a large, superconducting ring placed in orbit around the planet. This ring would create a magnetic field that could deflect the solar wind, protecting the Martian surface and any future inhabitants. Section 7. The challenges ahead. Technological hurdles and ethical dilemmas. While the concept of terraforming Mars is theoretically possible, it presents a myriad of technological and ethical challenges. Technologically, we are still far from possessing the capabilities to alter a planet's environment on such a massive scale. The energy requirements alone would be astronomical, and the time frame for such a project would likely span centuries. Developing the necessary technologies, such as advanced spacecraft propulsion systems, large-scale atmospheric manipulation techniques, and the ability to create artificial magnetic fields would require substantial advancements in various scientific disciplines and significant financial investments. Section 8. The moral compass of exploration, balancing ambition and responsibility. Beyond the technological hurdles, terraforming Mars raises profound ethical questions. Some argue that we have a moral obligation to preserve other planets in their natural state, even if they are currently uninhabitable. Others contend that the potential benefits of creating a second home for humanity outweigh these concerns. There is also the question of planetary protection. If life does exist on Mars, even in microbial form, terraforming could potentially harm or destroy it. Before we embark on a project with such far-reaching consequences, it is crucial to engage in thoughtful, ethical considerations and develop a plan that minimizes potential harm to any indigenous Martian life. Section 9. Mars. A future full of possibilities. Despite the challenges, the pursuit of terraforming Mars has the potential to yield invaluable scientific knowledge and technological advancements. The journey to make Mars habitable is filled with obstacles, but each step forward brings us closer to understanding the red planet and our own capabilities. Even if we never fully transform Mars into a second Earth, the research and development required for such an endeavor could lead to breakthroughs in areas like renewable energy, closed-loop life support systems, and advanced robotics. These innovations could revolutionize how we live and work, both in space and on our home planet, which could benefit humanity both on Earth and in our future space endeavors. The technologies developed for Mars could be adapted to solve pressing issues on Earth, such as sustainable energy production and efficient resource management. The exploration and potential terraforming of Mars represent a natural progression of our species' innate curiosity and desire to push the boundaries of what is possible. This drive has always been at the heart of human progress, from the first steps on the Moon to the current missions to Mars. As we continue to explore our solar system and beyond, the lessons learned from our endeavors on Mars could pave the way for even more ambitious space exploration and colonization efforts in the distant future. The knowledge gained and the technologies developed will be crucial as we set our sights on even more distant worlds, ensuring that the spirit of exploration and discovery remains alive for generations to come. Section 10. Join the conversation. The future of Mars is in our hands. The question of whether or not to terraform Mars is not one with an easy answer. It involves a multitude of factors that go beyond just the scientific and technological challenges. It is a complex issue with far-reaching implications, requiring careful consideration of scientific, technological, ethical, and even philosophical perspectives. The potential benefits of creating a habitable environment on Mars must be weighed against the possible risks and ethical dilemmas. As we stand on the cusp of a new era of space exploration, it is a conversation that deserves our attention and thoughtful engagement. What do you think? Should humanity take the bold step of transforming another planet? Should we strive to terraform Mars and make it a second home for humanity? Imagine the possibilities of a thriving human colony on the red planet. Or should we focus on preserving other planets in their natural state? The untouched beauty of Mars and other celestial bodies holds its own value.